Great job. Hello, BlueHat. How's everyone doing today? All right. Could I get a huge round of applause for all of the BlueHat organizers, all the MSRC folk? Thank you very much for having me. I know this is a huge effort, and I really appreciate it. Today, I'm going to be talking about variant hunting that we do inside of MSRC. Microsoft in general does lots of variant hunting. And if I was here to tell you about all the variant hunting we would do, it would take me the rest of the day. And while I might enjoy that, some of you might want to have lunch at some point. So instead, I'm just going to be focusing on hacking competitions. So a couple of big hacking competitions that we support are Tianfu Cup and Pwn2Own. I'm going to ask for a quick show of hands here. Who here has ever heard of one of these hacking competitions? All right, so that's a pretty good show of hands. Roughly half the people in the room have heard of one of these. These are super big deal competitions. These are really, really well known in the exploit developer community and the vulnerability research community. And in general, these competitions incentivize competitors to build fully working, reliable exploits against platforms like Windows. I'm going to focus on Windows today. Windows is my pride and joy. It is my love baby. I love it all day long. I work on Windows as much as I can because it's the space that I really enjoy being in. Now, there's very few competitions like Tianfu Cup and Pwn2Own. Tom was talking to us earlier about capture the flag competitions, where people will develop certain applications for these CTF competitions that are intentionally vulnerable. However, that's not the case inside competitions like Tianfu Cup and Pwn2Own. Instead, they're going after real, live, working platforms like Windows. And that gives us a really interesting space to look at. However, it's also the thing that MSRC is trying to stop. This is the #1 thing that we want to prevent from happening, right? We want to prevent these fully weaponized exploits. We also want to take a look at these new attack surfaces that continue to crop up in both Pwn2Own and Tianfu Cup. And we want to look at new and exciting exploit patterns from these competitions. So that's why paying attention to these competitions is really, really important to us. OK, let's talk a little bit about the incentives that these competitions give out to the researchers participating. For example, competitors are incentivized to ensure that their exploit is reliable. They only get a couple of chances to run their exploit. This means if that they try to run their exploit, and for whatever reason it doesn't work, maybe it's a race condition or it's not very reliable, they won't get the payout for their vulnerability. And I'm not joking, researchers spend months and months developing their exploit and going really deep into how their vulnerability works to make sure that it's the best that it can possibly be. They also want to make sure that the vulnerability that they've found, the vulnerability that they're exploiting, is novel. If another competitor finds the exact same vulnerability as them, they won't get payout for the vulnerability and the exploit that they build. What this means is that attackers will often find new and interesting attack surfaces and try to find new types of exploit patterns or vulnerability patterns and go after those rather than the tried and true techniques that we've seen before. However, these incentives are not what we want inside of MSRC. I want to build Windows and platforms like it to be as secure as possible. And going really in depth into a specific vulnerability and how you might exploit it is not the recipe for success to build the best platform possible. Instead, we need to go broader. We need to look at the entire ecosystem and not think about just one individual vulnerability. We need to widen our landscape to look at more than just an individual thing and look at the overall attack surface that we're seeing. One other thing that I want to talk about with these hacking competitions is that the research that we get in these hacking competitions often leads to more research in that same component. And there's a couple of reasons for this. First of all, these hacking competitions are super well known. The industry respects them, the industry knows them very well, and people get a lot of cred for going online and posting about these things. We often see that competitors in these hacking competitions will release proof of concept code. Sometimes they'll release detailed write-ups about both their vulnerability and sometimes their exploit. And sometimes they'll even post entire working proof of concepts, meaning that someone could go on GitHub after the issue's been fixed and run one of these exploits. So I'm going to take you through one example of this. This is in kernel streaming. This is a kernel mode component. Please excuse my bit of an ugly looking graph here. But this is essentially a local attack surface. So users have the ability, if they find a vulnerability in something like kernel streaming, they can elevate their permissions from a standard user on the machine to administrator on that machine. And what you'll see here is that there was a little blip in 2020. And to be honest with you, this is pretty normal across all Windows because people were sent home in 2020 and had nothing better to do than to sit around and hack Microsoft products. However, there's a pretty big gap, and then we saw one tiny little blip in 2023. And this was Pwn2Own 2023. After Pwn2Own, there's roughly a 3 to 4 month period where we're developing the fix, building the fix, and then eventually releasing that fix. We saw an explosion of research in this component. We saw active in the wild exploitation. We also saw another submission in Pwn2Own, and we saw roughly 50 MSRC cases submitted to us in this component. So again, this really goes to underscore the idea that the competitions really drive more research, right? These are very well-known competitions. It's probably half the reason that BlueHat accepted me to come talk here. And people really love to talk about them, and as a result, researchers will then flock to that component. So hopefully this is kind of getting across this problem statement. We have these super talented researchers who are going really in depth into an individual vulnerability and how to exploit that vulnerability, right? They really understand, they cultivate this attack surface and do everything they can for their one individual exploit. However, they don't go broad, right? They don't see the entire picture. They don't necessarily try to make platforms like Windows as secure as they can possibly be. So how do we solve this? One of the ways that my team tries to solve this is by internally doing variant hunting for every submission that we get from these hacking competitions. And if you don't know what variant hunting is, it's pretty much exactly what it sounds like. We start from the research that we get, and we make logical steps from there to find similar related issues. And we're looking for similar vulnerabilities to what's been submitted to us in the first place. So let's talk a little bit about this process. Typically, my team huddles together after Pwn2Own and tries to put together a post-competition write-up. To be honest with you, this competition write-up ends up looking a little bit more like a book, just because we really want to go super in-depth into the attack surfaces that we get. We want to do a very detailed root cause analysis, right? We want to figure out exactly what caused the vulnerability to happen and what an attacker can do with it. We also want to dive deep into how the exploit works, right? We want to figure out what this exploit is doing, what primitives it's using, and how we could potentially defend against this. One of the biggest things we can do in Microsoft to apply to all sorts of different vulnerabilities is write system class level mitigations, right? If we can build out a mitigation to prevent lots of different exploits, that's super powerful and goes beyond just the individual submissions that we get and applies those learnings to lots of different places. And lots of the exploit development teams, or the mitigation development teams at Microsoft, really look at this post-competition write-up. They want to understand the different mitigations that they're putting together and how the submissions from these hacking competitions apply to those mitigations. Right? If you're building a mitigation, you want data that says, hey, there's 10 actual working exploits that I could have prevented if I'd built this mitigation. And this really goes to inform a lot of future work that we do inside of Microsoft. And again, this is about so much more than just an individual vulnerability that we get. This is about the overall trends and the patterns and the attack surfaces that we receive. The final piece of this report is a really detailed write-up about variant hunting. We want to go in and try to find as many similar vulnerabilities as possible so that similar things don't crop up in the future. So let's take a look at two individual examples I'm going to be talking about Tianfu Cup 2023 and Pwn2Own 2024. In Tianfu Cup 2023, we saw 2 Windows elevation of privilege vulnerabilities. In Pwn2Own, we got 9 submissions in 2024, 6 of which were against Windows, 3 were against browsers. And I'm going to focus entirely on the things that I worked on. So I'm going to be focusing on 2 of the Windows elevation of privilege vulnerabilities that we got. So let's start with Tianfu Cup. In Tianfu Cup 2023, we received a submission against the RASman service. Now, if you've never heard of this, you have almost definitely used this service before. It works in the back end to help you connect to things like a VPN. And this is a local reachable attack surface, meaning that a local attacker might go after this because it's running as administrator on the machine. Something that's interesting about the RASman service is that we actually saw it 2 years earlier in Tianfu Cup. And then it cropped up again in Tianfu Cup 2023. However, inside of MSRC, we saw very few submissions from our normal vulnerability discovery community. Right? We run a really large bug bounty program, and we didn't see a lot of submissions through that bug bounty program against the RASman service. And this really raises the question, why is the exploit developer community looking at this service, but the vulnerability research community isn't? One of the other things about how this attack surface works is that there are many different input validation functions. Since we're over local RPC, we pass over some buffer that contains some user information. And these input validation functions will check that data and make sure that it looks legitimate. Every single RPC function has its own input validation function. This is going to come back in a little bit of time, so just keep this in the back of your minds. Let's take a look at the individual vulnerability that this researcher was able to exploit in Tianfu Cup 2023. So I've made this a little bit simpler, just kind of pulled out the lines of code that are really interesting to us. But basically what this attacker has demonstrated in this first line of code is that ADV_con params is a structure that is fully attacker controlled, meaning they control every single variable inside of this structure. We then pull out a number, this DWNum policy thing, from that structure, and we use it as a loop counter. Essentially what this means is that the attacker controls the exact number of times that this loop will run. And what's interesting about this is that this P custom policy structure is statically sized. I think there's only like 10 entries inside of this structure, meaning that an attacker can wait and run this loop 10 times, and after it's run 10 times, all of a sudden it's going to start writing out of bounds. And that's exactly what this attacker was able to use for elevation of privilege on Windows. Now, when we look at this chunk of code, it really begs the question, what is this ADV_con param structure? Where else is this thing actually used? Because we're seeing it, and we want to think, if we're doing variant hunting, let's use this as a starting point to inform our future research. So I took a look at this structure, and I saw this behemoth. This thing is massive. This is a really large structure. I don't expect everyone to read through everything here. The point I'm trying to get across is that this is a large structure that the attacker has control over. In total, there are 8 sizes in this thing. There are 7 numbers of objects, and there's 8 embedded structures. And this is a really interesting place for us to start our variant hunting. When I looked at that validation function for this place that I was talking about earlier, I noticed that there's very little validation on this structure itself. When we're thinking about doing variant hunting, we want to look at these places that don't have a lot of validation. And then we also want to think, what could we actually use in an exploit? And sizes and numbers of objects are both really good candidates for us to start doing variant hunting. That's because if an attacker can lie about a size, and the privileged code actually trusts that size, it will often lead to a read or write out of bounds. And this really begs the question, now that we're looking at this structure and we've seen so many different things inside of this structure, where else is this thing actually used? And the answer is a lot of places. I'm going to take you through one such example here. And actually, this thing looks remarkably similar to the entry that we got in Tianfu Cup 2023. In this case, once again, we are pulling a number out of this ADV con param structure. This time it's this DW num routes thing. And we are once again using it as a loop termination condition, meaning that the attacker again controls how many times we're going to run this for loop. And so once again, the thing that we're reading and writing into is statically sized, this p route structure. And all this means is that an attacker has to use up that static size, and now they're starting to read and write out of bounds. And again, this is a really powerful primitive that attackers can use. One of the main takeaways that I want people to think about here is that this is remarkably similar to the vulnerability that was discussed earlier, where this looks almost identical to the exact same thing that we found. And I hope this really goes to underscore the point that I made earlier, which is that attackers are incentivized to go really deeply in their research in these hacking competitions, but they're not incentivized to go broad. These competitors aren't incentivized to look for similar types of vulnerabilities. Instead, they're incentivized to look as deeply as they can in one individual area. Okay, let's take a look at this structure in total. So as part of the variant hunting for this structure, we ended up raising several different MSRC cases that became CVEs. So once again, I'm not expecting everyone to go through this, but hopefully this kind of gets across that point that I made earlier, which is that many of these fields were vulnerable inside this structure. And yeah, sometimes there's some extra things that you have to do to pass through validation, but in general, there were lots of different places that we could use this structure. However, we don't just want to stop here. We don't just want to stop with an individual structure. We want to take this research and use it as a starting point for future research as well. So one of the things that I was thinking about, is that we saw these sizes, these numbers of objects, and these were great candidates for us to look at for our first start at variant hunting. So I kept looking for sizes, things like embedded structures or arrays, but I wasn't able to find very many of them. And of the ones I was able to find, they all seemed to have proper validation, which is great. For whatever reason, it just seemed like that ADV con param structure slipped through the cracks. So now we need to start thinking outside the box, right? We still want to take this research and apply it to variant hunting, but we need to think of a couple of different ways of how we're going to approach this. One of the ideas that I had is that there are lots of different strings being passed around. However, for all of these strings, no sizes are actually being sent, which means that we're entirely reliant on the null terminator for each of these strings in order for us to do validation. And this raises the question, are these all checked for null terminators? And the answer, unfortunately, was not always. So I'm going to take you through one example of this. This is in one of those validation functions that I was talking about earlier. And in this validation function, we are adding a null terminator to two strings, this entry name and this phone book path. However, when I looked more deeply at this structure, I found there's actually 3 strings inside of it, but we're only doing validation on 2 of them. So let's take a look at this structure real quick. We have these first 2 strings. These are what was checked by that validation function, right? This entry name and this phone book path. We put in that null byte at the end of those strings to ensure that they're null terminated. But this final one doesn't have that. This user SID doesn't have that. And as an attacker, this is actually really lucky that this user SID came last in this structure. That's because since it comes last, you don't have to worry about other strings being null terminated. If you run into a null terminator on a line of code like this, right, this is just a simple string length, if we'd run into a null terminator, we would immediately stop reading out of bounds there. However, since this comes at the end of the structure, an attacker can potentially read past the end of the structure. And that's why this is really interesting to be used for something like information disclosure. So we ended up finding 3 vulnerabilities that looked very similar to this, where we weren't properly checking for null terminators. OK, let's take a little bit of a step back from Tianfu Cup. Instead, we're going to be thinking about Pwn2Own in 2024. This was a really interesting vulnerability to me, because this was a vulnerability in nt.sys. And for those of you that don't know, NT is a very well-known and very well-understood Windows component. This is something that's been around for a very long time, and lots of security research, lots of research in general has been done on this component. What we saw in this submission was a kernel double fetch vulnerability. And to be honest with you, this was a little bit surprising. because we kind of thought that we'd gotten rid of all the kernel double fetches. We were fairly confident from a lot of the static analysis tools that we'd run that we found many of these kernel double fetches. And so this was really interesting and piqued my interest because I wanted to know how one of these things had slipped through the cracks and then use the techniques that we learned to find more vulnerabilities like it. So I'm going to run through what a kernel double fetch vulnerability looks like first. So in this case, we have user mode who's making a call into kernel mode. And they're going to be passing in some buffer, and that buffer is going to have a size. This is a very common thing that we do. Typically, we have to pass some information from user mode to kernel mode, so we want to involve some sort of buffer where we can actually transfer our information. And the start of this buffer will tell us how long the rest of the buffer is. So in this case, we've set the size to 5. For example, that might be there's 5 more bytes inside of this buffer. And kernel mode's going to want to copy this structure over, right? It's going to want to check the size and then eventually try to copy this information over so it can do whatever work it needs to do. The first thing it's going to do is go into this structure and find that the size is 5. Maybe kernel mode has already allocated 100 bytes of space for this buffer. It's going to say, that's great, 5 is less than 100, so this is going to be a totally allowable request. And then kernel mode is going to go back into the structure, and it's going to grab that size and use that for a mem copy so that kernel mode can keep working on it. The issue with this vulnerability is that there's a small timing window in between when we do this check and when we actually use this size. And user mode has the ability to interrupt execution at any time. So all that user mode has to do is change this size variable to something really large, like 333, and now all of a sudden we're going to write past the end of the buffer. So this is kind of your canonical double fetch vulnerability. However, what the researchers submitted to us looked a little bit different. So instead of a size being passed around, they were passing around pointers inside of this user mode buffer. So on this first line of code, we have this Pout attribute thing. This is just a user mode buffer. User mode can edit this at any time. And kernel mode is writing in a pointer inside of this name.buffer field. So now we've got this pointer that's been written by kernel mode. On the second line of code, it's a simple string copy. But what string copy does is it will go to the pointer, it will follow that pointer, and then it will write to that location. But once again, there's a timing issue here. An attacker can overwrite the specific pointer that kernel mode wrote there in the first place and cause this to write out of bounds. And this is actually a really, really powerful primitive because the attacker controls both the exact location where this write happens as well as the contents of this write. And the attacker in this case did an excellent job, had a great write-up for how they were able to exploit this issue. Okay, so I started thinking about how we're going to do variant hunting for this individual instance. And this was kind of a difficult problem to solve. That's because it's hard to tell what's always a user mode buffer and what user mode might be able to control. We also want to be able to look beyond just NT, right? We don't want to finish our research with just one individual component. We want to be able to apply the learnings that we have across many different components. So I reached out to some folks in our Windows CodeQL team. Shout out to Ben Rhodes. He's a great help for us over in Windows CodeQL. And he helped us build a CodeQL query to identify patterns of this vulnerability, right? Places where we're writing pointers into this user mode buffer that user mode can interrupt, and then kernel mode once again trusts. And we found several different vulnerabilities that looked very similar to the individual thing we got from Pwn2Own. I'm going to walk through one of those examples. So again, this looks fairly similar to what we saw in Pwn2Own. This time we're working on Pout attributes. So Pout attributes is once again this user mode buffer that user mode can interact with at any time. This time around, we're trying to build a doubly linked list inside of this user mode buffer. So what we're doing is we first call initialize list to actually create this list. And then secondly, we call insert tail list to go through and insert an object into this list. However, once again, there's a timing issue here. That's because for those of you that remember how we do linked list insertions, you go to the current object that you have, you follow its next pointer, and then you write to that next pointer to insert a new object. The issue is that all of these pointers exist in this user mode buffer, and all that kernel mode has to do is interrupt this and change one of these pointers, and all of a sudden it's going to be pointing at somewhere malicious or somewhere attacker controlled, and an attacker can use this for elevation of privilege. Okay, so let's talk about some overall results from this research that we've done. First of all, in Tianfu Cup, we received 2 Windows submissions. And in Pwn2Own 2024, we received 6 Windows submissions. In total, in Tianfu Cup, we identified 12 variant vulnerabilities from the 2 submissions that we got. And in Pwn2Own, we saw 5 variant vulnerabilities that we were able to discover internally that were very similar to the original vulnerability. And again, hopefully this goes to underscore that earlier point, which is that in these hacking competitions, people are really incentivized to go super deep into the vulnerability that we've found. However, they're not incentivized to go broad. Our normal bug bounty programs would incentivize that, right? We want people to find every single vulnerability they can because that's how we build the most secure systems. However, these competitions don't necessarily incentivize that, so we have to go do a lot of that work on our own. Okay, I'm going to leave you with a couple of thoughts before I get going here. The first is to participate in responsible disclosure. You guys are already all doing this just by being here at BlueHat, right? We're starting this conversation and we're talking about responsible disclosure. But we want more of it, right? We want more researchers involved in this space. We want more people to be excited, be interested about places like Windows and new attack surfaces in areas like Windows. Secondly, if you do own a component or a service or something like it, I want to encourage you to look at security research as so much more than just the individual vulnerability that you receive. The individual vulnerability is just a tiny piece of what goes into security research. However, the real interesting details are the things about the attack surface and the overall scope of what the researcher has discovered. And if you're not receiving security research, that's okay too. Go online, go find some security research that's going on, and use the learnings that other people have gleaned from the security research that they've gotten and apply them to your own products. Static analysis tools, dynamic analysis tools, these are all great ways that we can take a step back from the first vulnerability that we receive and really take a step back and understand the entire trend and the scope of where we're going. So with that, thank you very much. My name is George. Please come find me to talk about this more. I'd love to. And thank you very much.